Good afternoon, everybody, and welcome to the MSc Electrical Power Engineering webinar. Thank you all for joining us. Hopefully, most of you will know who I am now, but my name is Craig Donaldson, and I am the course advisor for the course. Just to give you an overview of how the webinar will run today, you'll receive a presentation from my colleague, Dr. James Brooks. He will go through the course, breaking it down for you. Towards the end, or as the webinar is moving on, you can send through your questions, and as we reach the end of the presentation, James will answer any questions that you have. And with that, I'd like to introduce James.
Thank you. Thanks everyone for joining. Go through slide. So, as Craig said, I'm the course director for this, so I'm sort of responsible for looking after the course as a whole, working quite closely with my counterpart who looks after the on-campus version of this. I'm a senior lecturer in electrical engineering, but I'm also the academic lead for pedagogy. So I really focus on how do we try and improve the quality of education, the quality of teaching, and a lot of that will come through in how I've designed this course. Back when I did my PhD, he was looking at kind of future power systems with a lot of renewable power and saying what are the risks involved there and how do we quantify and look at them. But it's not just me, there's quite a large team who've developed this. We've had input really from quite a wide variety of people, all who work within the University of Manchester within the Power and Energy department. So we've got people who focus on future power systems, on substations, on almost kind of chemists looking at the degradation of oils within transformers, people looking at protection systems, risk and reliability, cybersecurity, a variety of different aspects. And it's really great to be working with so many people who are top of their game and hear their insight and learn from them. And in terms of what the course is, I sort of break down electrical engineering into kind of the high power stuff and the low power stuff. We're obviously the high power stuff, and there again it can split down into the machines and drives and power electronics, the sort of the specifics of designing devices, and then the system as a whole. And that's what we look at, the whole system, from generation, transmission, distribution, and consumption. And that involves, what are the components? How do we analyze them? How do we operate them? When we've got a fleet of say, transformers, how do we monitor and manage them? How do we quantify and maintain reliability? How do we protect them? And then what's coming? What's the new technology? What's the new innovations? What's the new trends? So that's what the course is. And it's really of a growing global importance. The sector is growing massively, and I sort of see that as being driven by three main things. There's obviously this decarbonisation, the clean energy, and it's interesting that that's driven both by kind of governments and international organisations, but also kind of from the ground up by consumers. And that's what's driving a lot of this change. And then linked with that, there's a lot of research that's creating technological advancements. A lot more power electronics are being used. There's new forms of storage or cheaper forms of storage. There's a lot more electric vehicles. There's new photovoltaics or cheaper photovoltaics, and there's a lot more wind power being used. And then the final kind of big driver of change is that so much more now is becoming electrified. So electric vehicles and railways, but also heating as well, with sort of combined heat and power. And those three drivers are giving us quite a vastly different network, a vastly different kind of look at the power system and some challenges. And I'd originally said these were future challenges, but actually all of them are current challenges. They're just going to be of increasing importance. So split them down into three. For generation, and most of this sort of new generation is renewable or low carbon in some way. But the challenges are, one, it's distributed. And that might mean you're looking at long lines far away from load centers rather than having one big power station with a very strong connection. But it also might be that, if you install a solar panel on your house, the system operator might not know that that's there and might not have the information. they're non-synchronous, and this sort of synchronicity of rotating machines means that it's easier to hold the frequency stable. When that decreases, when you've got more photovoltaic solar panels, that means that the rate of change of frequency can go up, causes problems. And then finally, they're non-schedulable. And that, you know, in a gas power station, you can say, open a valve, increase the power output. You can't tell that to a wind farm. It will produce, well, the amount that the wind blows. And the way you deal with that change in generation is really interesting. So that part's an interesting time. But then on the demand side, firstly, there's this increasing demand because of the electrification, but there's more storage, which changes when demand is. It also changes how demand can be used. And that sort of links into increased participation. There's smart charging schemes, smart devices. There's more involvement by consumers of power to say when they want to use it, for them to optimize, to save money, to really be greater participants in that system. There's a lot more electric transport, as we talked about, and then looking globally, there's a lot more kind of rural electrification, which brings its own challenges. And then finally, as a system as a whole, which is our kind of real focus, we're just seeing increases all round. There's more information, and with that becomes more control. And because things are more interconnected, because there's more IT systems, more kind of networking, there's an increased cybersecurity risk. Climate change brings more extreme weather, which we are seeing, and all of this requires more intelligence and automation, so that you've got systems that can automatically recognize certain problems, certain opportunities, and either inform an operator or automatically respond in some way. So it's a really kind of, there's a lot going on within power systems at the moment. So it's a really exciting area and exciting time to work in this. And that kind of breaks down into the units that we actually deliver. So the first one is about just getting everyone up to speed. It's introducing the topic, but it's also getting people used to academic research. It's getting people introduced to each other. There's a large discussion element to that one, and talking about the ways in which different power systems differ. I really want you to learn from each other in this one, as well as kind of find a good kind of grounding of the basic maths that are needed for the rest. Then we jump straight into analysis, power flow, faults, analysis of how you'd model sort of power electronic systems in there, and some of the kind of what's going on when you're doing a load flow, what are the complexities, if it goes wrong, what could be happening. Then we jump kind of from the purely kind of computational to physical kit. What's in a substation? What are the design decisions there? What are the components that each piece of plant is made up of? And if you have a suite of switchgear, lines, cables, how do you monitor their performance over a long period of time? And what is your asset management plan? And again, then we jump back up to the top level of, well, yes, there's a load flow, but what that's driven by, what the power output of each kind of generator is driven by, is economics. And even kind of where new lines are installed is driven by economics. So that's a really nice mix of mathematical optimization and talking about the ways people interact with different markets around the world. Then we look at kind of this smart grids unit is looking at the future, or looking at the coming challenges and changes. And this is where we really start to explore what's new, and how will that impact kind of the real details of the voltages and powers for a particular component. Then we're looking at dynamics, quality of supply. So that's saying, okay, well, not everything is a perfect sine wave. There's going to be differences. There's going to be harmonics on there. And this kind of is sort of tied into the power electronics, the new devices, the new problems that can come up with those. Then we look at protection, and what are the different types of protection? How do you configure it? How do you ensure it's kind of doing what you want it to do? And then all of those taught units kind of come together to a group project where we talk a bit about kind of performance management of teams, because you're working in a distributed team. And then I just want you to pitch me an innovation, some kind of exciting new technology that you've come up with based on what you've learned across the rest of the work. So that's kind of what the units are as they stand now. We're always kind of tweaking and improving them, but that's the pieces.
And each of those 8 units last 6 to 10 weeks, and within that there'll be the assessment.
So 4 of those, that assessment is a coursework. So you'll be doing a substantive bit of kind of research or mini project, and then 4 of those you'll physically go to an exam centre and sit an exam. We've got exam centres all around the world that we work with for that. You can do 4 of those units a year. So, but some people choose to sort of take 2 or 3, depending on holidays, big kind of work deadlines they've got. But minimum 2 years, you have that piece, that sort of taught element finished, and then you start your research project. And what I want out of that is something that not only benefits you, but ideally benefits your company as well. Often we can kind of form good collaborations there, where people are working in a particular area for their job and can tie that into their dissertation. So this is a big research project. I say minimum half a year for that, but generally it takes people a year. So between a year and half a year for the dissertation itself.
And this is what our learning space looks like.
This is for the smart grids unit, and you can see it sort of split down into 6 different sections. The number of sections varies depending on kind of, is this an exam-based unit? Am I expecting you to do a lot more coursework and self-study? And in this one, we're looking at low carbon technologies. And if you go on, here's an example of kind of one of the activities from this, is to watch this short video, which is sort of saying, okay, here's a distribution line with a number of houses connected to it. How many electric vehicles can you actually put on this on these houses before one of the components on here becomes overloaded? And so there's a little explanation of kind of how this works, what the limitations of the technique, and then how do you solve it. And then going on from that, there's a discussion activity where you'll talk with your other students, posting messages to each other. But there's a whole load of other things we use. So there's quite a lot of short videos in sort of a lecture style. Some are kind of worked examples like we'll see here. We've got things where people are asked to discuss a particular topic, to work through question sheets and get feedback. And in terms of the feedback for each unit, you'll be a tutor. This person will kind of know in detail about the subject, and they'll do probably every other week a video conference, a bit like this one, where you've got an opportunity to ask questions and get feedback and discuss things. But you can also email them and sort of, you stay in regular contact there. And we also provide access, or the library provides access to a number of books, and we'll recommend sort of specific sections of those. And you have access to IEEE Explore.
In terms of kind of why come to this course,
firstly, the University of Manchester is a leading university. We've got a number of Nobel Prize winners who've kind of worked or studied here. A large percentage of our research is kind of excellent, according to the last Research Excellence Framework. We're a top university for graduate employment, and obviously then that means we're one of the best in the UK and in the top 30 in the world, according to the last QS World Rankings.
But specifically the Power and Energy Group really does shine that we've got probably the longest running power systems course in the world, established in the early 60s, and our research is like internationally renowned.
You get employers from a number of different industries. You'll get equipment manufacturers, distribution companies, transmission system owners, and there's great discussions that happen between them.
In terms of entrance requirements, you need a good degree, first or a 2-1, or whatever the international equivalent is, in something like electrical engineering, where you've got a good background. But then we'll go in, factor in what are your grades in relevant units, things like power, maths, etc. What's the standing of the institution where you studied and got that degree, and what's your industry experience like?
You also have to be able to complete this work-based dissertation. You have to show that you've got competency of English, and you have to be able to pay the fee, obviously, which differs from UK and international.
When you're actually studying, we've designed the course so that you're doing about 15 hours a week for 40 weeks a year, and I plan that over about 3 years, although you can spread it out, as I sort of said before. You've got to be able to go to the exam centres and do those 4 exams and be able to do video conferences like this in a nice quiet space. And you've got to have a computer that can run the software. So we ship you a number of sort of standard bits of software, IPSA, PowerWall, PSCAD, and MATLAB, and you'll be doing simulations on those.
There's me. Thanks, James. Thank you to everybody that has joined us for the webinar. This is an opportunity now to send through some questions to James that you might have about the course that might be a little more technical than the ones you've sent me. I think we have received a couple at the moment. I did see some that came through. Just while James is having a look for those questions, I'd just like to remind everybody about the closing date for your applications if you are considering applying for the February intake. So around about now, you should be working through your application forms, and the closing date that we would like them to be by is the 1st of February. That gives our admissions officers some time to go through and request further support and information if required. And the course will begin towards the end of February. I think it's the 24th of February, but I will confirm that. You'll receive confirmation details, obviously, if you're successfully admitted onto the course. And I think we do have some questions that have come through. I think, Freddie, yours is the first one to come through. And do we have to complete any practical exercises during each term, James?
Yes. So I think pretty much all of the units have some software-based lab or kind of mini research project there. So just on that previous slide, I think I showed you IPSA, PowerWall, PSCAD, and MATLAB. There'll be projects within those where you're, for example, looking at what is the maximum amount of wind power you can connect to this congested network, where's the optimal place to put that, or looking at design studies where we'll give you pieces, we'll tell you how to use the software and you're kind of running projects for that. There's no requirement to physically come to university to kind of do practical labs in that respect. We've designed it so that you can do it remotely, so it's got the most flexibility. Okay, next question. Special computer equipment. So one way option is just to kind of go onto the websites for these bits of software and look at their requirements, or you can contact us and we can let you know the details. But really, it's a PC that's relatively modern, should be able to run most of these. The fact that you're on the video conferencing tells you can run something relatively fast. You've got an internet connection.
See one just above there.
Yeah.
Asked, what time do the video conference tutorials tend to take place?
So when you first kind of are accepted to the course, a week or so before, you'll have an induction, and we'll ask kind of that cohort, when's a good time for you? Obviously, we've got people based all around the world, and we've got people on shift work, and their shifts change. So we can't kind of get everyone all the time. What's tended to happen for these ones is it runs kind of about 5:30 till 6:30 UK time in the evening. Some people stay late in work, some people have managed to go home and do that then, but they're all recorded and questions can be submitted beforehand to be answered. So if you can't attend them, you still have that opportunity to get feedback and to watch them back.
Harriet has asked one. February or September, Do modules take 10 weeks? Do modules start in both February and September? Or is the order of modules studied differently depending on when you start? So I guess, yeah.
So the course starts February and September, and the first 2 units have to be taken in that order. So there'll be one that starts in February, runs for 10 weeks, and then another that starts in May and runs through. And then you'll be kind of mixing with the other cohorts to take units as they're available. So sometimes there's options available for you to take, and then there's a sort of a path through them. Yeah.
Engineering in my first degree, can I study this course?
I would have to see the specific units you've done, and this kind of goes more generally. If you've got a good understanding of kind of circuit analysis of maybe modeling in MATLAB and estimating kind of modeling, and you can evidence that, you've also got a good knowledge of engineering maths, and I'd again dig through kind of what units you've done, what grades you've got in those, then you're more likely to get in. But it's hard to say just from a degree title because I don't know what's in there. Yep, okay. So the PG Cert is 4 units, 4 taught units. So you have to take the first 2 as their prerequisites and sort of set you up for everything else. And then it's up to you. You can pick 2 others. You can't pick the techniques for research and industry, this group project, because that's kind of a culmination of all the others, but you've got quite a lot of flexibility there in the 2 options that you pick. And the entrance requirements for them are the same. You've got to have those requirements to get on the course regardless.
Anyway, in the course?
No, we don't use ETAP. I know of it, and I know some of the researchers do use it. I can't remember it off the top of my head. It might be possible for you to do a dissertation project using that software if kind of you've got access to it and you've got a project you want to work on relating to that. But I'd have to check that there's an academic kind of wanting to do that and then kind of in that area. But no, the bits of software we use are the ones on the screen at the moment. IPSA, PowerWall, PSCAD, and MATLAB.
Mahmood asked, what qualifications are you looking for in a candidate, and what types of candidates is the program designed for?
Yeah, okay. So good evidence that you have a strong knowledge of engineering maths, that you really know circuit analysis well, kind of AC circuit analysis, and Fourier-Laplace transform. Those are the kinds of things I'm looking for. As I said, I'll also look, you need an honours degree or whatever the international equivalent is at 2-1 level as well. And then in terms of the candidates, showing me that you're still in the field, you're still working in this area, is another strong case when you put your application forward. Kind of what some people have done that's worked quite well before is say, you know, I am responsible for this within my company. This links to this particular unit that I really want to study that's on the course.
Freddie has asked another question. Mission centres, are they located just in the UK or are they spread out? I think you may touch on that.
Yes. So there's one in Manchester, there's one in London, but we've got in the UK there's a half dozen, and in most countries around the world there'll be at least one. Yeah, we partner with other universities. The University of Manchester has overseas centres in a number of places. The British Council will often partner with to run exams. There's a few options.
I think I can add to that, James, is if you are successfully admitted onto the course and you are working with your study advisor, they will help you identify the examination centre that's obviously close to you and who we work with as well. Innocent has asked another question again. Is attendance of the video conferences mandatory, obviously to complete the course?
Not mandatory, highly recommended. We chose not to make it mandatory not least because we've got shift workers on who can't make everyone. We do strongly recommend that you submit questions before the video conferences and watch the recording of the video conferences afterwards, so that you get this feedback and interaction, because it's something that's so important to learning.
Mahmood has asked another question. The course fee mentioned, is it a total course fee or is that per academic period?
Yep, let's go back to the course fee. So that fee is for the course. Obviously, you'll have to, if you're thinking of other costs to factor in, there's the cost of you getting to the exam centre, but then we'll pay for the exam itself. But yeah, that's the cost for the course, whether it takes you 2.5 years or 4 years.
Thomas has asked, are we able to use lab spaces at the University of Manchester? Should we need for our dissertation project, as an example?
Good question. We haven't had anyone do so far. I think that's maybe a discussion to have later on. I'd have to be mindful of this, given the number of people and access to lab space. We tried to design this course really so that it can be done at distance wherever you are in the world. But if you do happen to be close to Manchester, yeah, maybe it's worth just having a discussion about that. I know some people who live close by who are doing their dissertations now do come in to see their supervisor to have one-on-one discussions in person rather than via email or Skype.
Right. Okay, I have over 5 years experience. This was asked by Infant. 5 years experience working in the sector. Would that be a problem?
Yeah, so a lot of people come into this course having been out of education for quite a while. That's absolutely fine. In fact, when I kind of dug through the stats, the people who've been on the course, it's more about how well you knew the material, the prerequisite material, when you originally did it, rather than how long ago it was. I know on the entrance requirements, it does say that you have to have completed the course within 5 years. I do take into account that time period of how long ago you did it. But honestly, if you had first and it was 6, 7, 8, 9, 10 years ago, I'm less worried, as long as you really show you've got a great understanding of those prerequisite units.
Thomas has asked, will you receive a university email address and or Microsoft Office program access?
Yes,
yeah.
Basically. So you're treated as a student of the university. You have access to the library's facilities, on huge amount of online facilities and resources. You kind of get a student card, you get the email address. Yeah, you are a student at the University of Manchester.
Possible. Andrew, an ability to do a bridging course if initial requirements are not met for the MSc.
I ask this a lot. I don't know of, we don't do one, and I don't know of a great one for this, and it's a real shame. It's something I may look at kind of long term in the future, because there are a number of people in your situation, Andrew, who don't have the requirements to get onto this course. They don't have a 2-1 honours degree, but are working in an ideal industry and kind of would really benefit from the course. Yeah, but sadly not something we have at the moment.
Harriet has asked, if you are accepted onto the course for February, but for some reason can't start, can we defer until September?
Yeah, this happens. You could also apply for September directly, or just say, look, we can't start until September. Yeah, I understand that sometimes it takes a while to get fees from the employer. If your employer can agree to pay the fees, sometimes we can work it out so that you'll start, and as long as we've got an agreement from your employer that they will pay, that'll work. But yeah, that can be done. Yeah.
Another question. So Andrew has asked, how do we go about checking if previous non-electrical qualifications are sufficient to get onto the PG cert prior to submission? Speaking to someone direct when I apply for the budget. So I think the first part of that, James, is just if we can check the qualifications are eligible even if they're not.
Get in contact is probably the first thing to say. Either reply and I'll go through everything in detail, or if you just send an email to Craig, and he'll kind of be able to give you some advice there. In terms of a final decision, you need to apply properly to actually be able to say yes or no, because we sit down kind of as a group and really go through things in detail. But yeah, just get in contact with us and we'll let you know.
Yeah. We have a couple more coming through. Thanks, Ernest. The content is really interesting. Andrew was asked again, further to the previous question. I have a 2.1 honours and masters both in engineering subjects.
Okay, right. So there's the follow on. Even though it's in engineering, I'd look at the specific units that you did. But 2 honours degree sounds great. MSc, again, if it's in a relevant area, fantastic. And sometimes, you know, engineering, looking at maths, power systems, more so rather than kind of engineering management units, which hold less weight for this course because it really is quite a technical and difficult but rewarding course.
Our final question has come from Innocent, which is how long will the feedback take after submission of the application form?
Yeah, okay, as quick as we can, but in terms of time, once you've got all the details in, we'll respond. Normally I have meetings every few weeks to kind of check through the details and then we'll get back to you. But actually often there's a lot of emails back and forth during the application procedure. So when you send your first details in, there'll be, you know, can you clarify this? Have you got more detail on this piece? So, you know, it's a conversation there as well. Excellent.
Yeah, thanks for everybody that sent through some questions. I mentioned earlier, if you do have any more, or once we finish the webinar, please do send through to me. I think my details were just a couple of slides through. Sure. We're still on the questions. There we go. Yeah, so most of you should have my contact details, but please do email or contact me if you have any others, and I'll certainly send them through to James if I can't answer them. And I guess the last thing is that we do hope to receive some applications. Thanks again for joining us.
Yeah.
Cheers.